Hey everyone, Geophysicist Stefan Burns here. We have just had a magnitude 6.4 earthquake right off the coast of Papua New Guinea. This is the strongest earthquake that we've had in quite some time. And so it looks like global seismic activity has gone back to high levels. It's only been moderate and low levels for the past few days, and we've been in a little bit of a lull if we consider a longer time frame. Back on March 28th, for example, it was extremely high with that magnitude 7.7. We've had some magnitude 7 plus earthquakes since then, some high magnitude 6s. Now we've been going down, but the sun remains very, very dynamic. We have this massive coronal hole. I've been talking about this a lot. And so today we're going to discuss another factor as it relates to how these coronal holes on the sun affect the energetics, not only here on Earth, but of the entire solar system. Because normally we see these during solar minimum, and they're around the polar regions. We'll look at some of that imagery from past solar cycles, the last solar minimum. Right now, though, we are in solar maximum. We are about to have a very low sunspot number for May of under 100, probably actually under 80 for the month, which is going to be a massive drop in our sunspot number. So maybe we entered into the descending phase very early. I do think we're going to rebound out of that. But the point is that to have these massive coronal holes and to have them fairly close to the solar equator is quite anomalous, at least for our records of solar activity, which, let's keep in mind, is extremely limited if we consider the actual lifetime of the sun. So in that context, all this is probably totally normal. The sun has a lot of expressions, but it does seem that the sun has given up a little bit because we have these huge patches now in the corona, the outermost atmosphere of the sun, where there is no plasma anymore. And these magnetic fields are open and they extend all the way out deep into space. They don't loop back and connect to the sun. And this has implications as it relates to the heliosphere. Because of solar maximum with the solar flares and the coronal mass ejections, normally the heliosphere is at its strongest, and as a result, it directs more galactic cosmic rays from outside and around the solar system to go in other directions, because these are very highly charged particles emitted from different galaxies and stars and explosions and such. And so when they hit these magnetic fields of the heliosphere, they route around. But right now, in solar maximum, when the heliosphere should be strongest, in fact, these coronal holes are weakening it because they reduce the dynamic pressure of the solar wind because they're of such a low density. High velocity, but very low density solar wind. And that causes the heliosphere to shrink. And when the heliosphere is shrinking, you get more galactic cosmic ray flux. Now, how does that relate to earthquakes? Well, there's a moderate correlation between galactic cosmic rays coming in and earthquake, and specifically global seismic energy release. And that is because we see this connection between what happens with the atmosphere, specifically like the ionosphere, and also with troposphere. For example, like a cyclone can move over what they would call a matured fault, a fault that's near its critical stress threshold, and cause it to rupture. And we have a lot of examples of that. And these galactic cosmic rays get absorbed directly into Earth's uppermost atmosphere, the ionosphere. This can cause ionospheric disturbances and create these atmospheric gravity waves. And this can also interact with the lithosphere and trigger perhaps earthquakes. This is still a connection that we're exploring. So we have a sun that is in solar maximum, but has these massive coronal holes, which are causing the heliosphere to be weakened. There's already a lot of correlative evidence between coronal holes and giant earthquakes. We've been talking about that in depth. But the fact that the heliosphere is very likely shrinking as a result of the reduction in the dynamic pressure of the solar wind means that we should expect galactic cosmic ray flux to start rebounding to increase. More galactic cosmic rays coming into the Earth geophysical system is going to change the parameters and the geophysics of the atmosphere, namely the ionosphere and all the layers down to the troposphere, and therefore that could cause global seismic energy release to go up. So that's what we're going to explore in today's video. Again, this is not the end of the world. I want to be very clear with that, but these are rhythms and trends that we see and observe and that we're learning a lot about. There's a whole wide range of expression for the sun, the earth, the other planets. We've been living in a interglacial period, so things have been in general fairly nice, and we're used to that, and we like stability, you could say, and in reality, the earth is much more dynamic than the current epoch that we've been living in, let's say for the past 12,000 years. And the sun also has these regular rhythms of activity, but it probably has a much wider range of expression that we don't have direct experience with. The biggest thing that we've seen with modern historical observations going back to the Carrington event, which is actually when we had our first observations of a solar flare. The first solar flare we ever saw was the Carrington solar flare, which perhaps was a magnitude, it was like an X64 flare. That's one of the estimates for that. Massive, massive solar flare. That range is very limited. So this is probably very normal, but in the context of what we've observed thus far, it's quite atypical. So that's what we're going to explore today. Let's get right into, before we get into some of this heliosphere data, let's get right into our earthquake for Papua New Guinea, because that just popped off. And we have that right here. So this is the location, and you see it's just right off the northern coast there. And it was at 15:05 UTC today, magnitude 6.4, and the Ring of Fire seems to be reawakening. The interesting thing I just wanted to mention here, I'll probably do a dedicated video on this, but I find it interesting that we have all these planetary resonances going from now through 2026 with Saturn and Neptune, and they're crossing over the 0-degree mark between Pisces and Aries, Pisces being water and like the deep ocean, and then Aries being fire, exalted sun. It's like this initiatory energy, right? And there's nothing really more initiatory than like a new volcano erupting. And we're seeing all these prophetic visions for like July of 2025, both out of Japan and Thailand, both lining up with saying that something volcanic may occur in this area and trigger like a really big tsunami. And that's a perfect expression of the planetary resonances that are currently active with Saturn and Neptune doing that conjunction at 0 degrees of Aries, the very first degree of the zodiac in February 2026. So there's a lot of ways that could express itself, but it's interesting how this narrative is kind of taking shape. And we see all the volcanism that exists across the Ring of Fire because of the subduction of the plates. And you know, you have tons of volcanoes in Japan, of course, all throughout Indonesia, the Philippines, like this whole area is super volcanically active. Those are the volcanoes that we see on land. What about all the volcanoes that are underwater that we do not see, right? There's a lot. Keep in mind, most earthquakes from volcanic activity are quite weak, so under magnitude 4. And the global seismic network really only picks up earthquakes magnitude 4 and greater. So unless you have seismographs really close by, you're not going to get those magnitude 3, magnitude 2, negative magnitude earthquakes even from, let's say, undersea volcanic activity. So our understanding of what's happening at depth in the deep abyss with these volcanoes is very, very limited. We are seeing, though, for example, Hawaii is having some, maybe you can't call it record eruptions, but Kilauea has been exceptionally active, right? That's fed from a deep mantle source, like a hot spot, right? We've seen Campi Flegrei recently be really, really active back in 2024, April, May, also this February, a seismic burst, and then also a 4.4 just recently in Campi Flegrei. Right, our super volcano fed from a hotspot, Vesuvius just nearby. We have this hotspot volcano that is off the coast of Oregon and Washington, right? The axial seamount, that seems to be waking up. There's Iceland, which is fed by a hotspot. That has been very, very active. We have a lot that is happening right now, and it seems to be coming from the deep mantle. These hotspot volcanoes really seem to be active. And the thing to keep in mind there is one of the ideas as to why there's a correlation between galactic cosmic rays and earthquakes is that if earthquake activity is driven in some part from changes to the geodynamo, which is what creates Earth's magnetic field, or at least that's one of the leading ideas, right? This magnetic field generation. If changes to that influence earthquake activity on a more global, longer time frame, the magnetic field also determines how many galactic cosmic rays we receive and observe here on Earth. And so that's why there'd be a correlation. It's not necessarily that galactic cosmic rays are directly causing earthquakes, so we do know that they influence cloud formation. There was just a research paper that came out suggesting that they actually create the ionized channel for a lightning strike to occur within and then to release that potential energy in a thunder cell. So there's probably a combination of these things. But the galactic cosmic ray flux could also be an indicator of how the geodynamo of the Earth itself is changing, therefore the magnetic field. We do know that the magnetic field of the Earth has been moving very rapidly, the northern pole at least, the positive, the negative polarity pole has been moving very rapidly from Canada to Siberia, though it has slowed down recently. So a lot to discuss in today's live stream. And I want to show you this graphic here. This is pretty interesting. This is from NASA. This is great because it shows the coronal hole and it shows the solar wind, and we'll see this change in the magnetosphere of the Earth. So here the coronal hole is now rotating basically into view, and you see this compression of the magnetic field. That's that high-speed stream. That's what we're in right now because this coronal hole is huge. We're still transiting that geoeffective position of it. So we are having changes to our magnetic field as a result of that, but there's also larger heliospheric changes as a result of these coronal holes because of the change in the dynamic pressure of the solar wind, which causes that dynamic pressure goes down, then the heliosphere is going to shrink a little bit. And it's going to let more of these galactic cosmic rays in. And typically you get more galactic cosmic rays during solar minimum, but right now we're in solar maximum. So it's a little bit of a oppositional thing right now. Like, we wouldn't expect the heliosphere to be weak, but it seems evidence would suggest that it is weakening right now as a result of these persistent coronal holes that are on the sun that have been rotating on the sun now for a while. Let's just give that a look one more time because it's really, this is not something you see every day. Again, the 9th rotation's only been getting bigger and bigger since October. 9th rotation has been very, very large. 7, 8, and 9 have all been about the same size. It's kind of hard to exactly judge which one was bigger, but 7, 8, and 9, all about the same size. Or they have been different sizes with slight differences, all very, very, very large. And so that's the thing. If this had only opened up for two months or so and then closed back up, well, okay, maybe the effect on the heliosphere isn't that much because it's kind of a transient influence. But if it's there for 7 months, 8 months, now we're really talking. Going back to October, that's a long time. I mean, we're getting close to, will this thing last a year? This coronal hole perhaps will be on the sun for a year. So let's look at some of the differences between solar maximum and solar minimum coronal holes. This is just a post that was put out by NASA, the Scientific Visualization Studio. And this is just like a sample, okay? So this is not the only one. But here we see an example of coronal holes on the sun in 2019, which is during solar minimum. And so you see that they're quite large, right? I mean, this is fairly large. We get some down there. We see this really big one at the poles, right? Most of the studying that's been done on how coronal holes affect the heliosphere is discussing these polar coronal holes. But in this case, we're looking at these more transequatorial ones, you know, at least closer to the equator. Now here we have an example of solar maximum, and you see that, and this is going back to 2014, April 2014. And you do see a coronal hole on the sun there, this guy. It's moderately large, but it doesn't look like solar minimum. Which one are we in right now? If you were just like, if you didn't know anything else about sunspots or anything, if you were looking at our sun right now, would you say it's closer to solar minimum or solar maximum based on how the sun looks? Well, it looks a lot more like solar minimum. It's not. We're not in solar minima, but that's showing the odd kind of properties of the sun right now, at least from our observational standpoint, which is very limited in time. Keep that in mind. So you do get coronal holes during solar maximum, as this video shows here. Again, you know, pretty big, but moderately large, but not massive like what we're seeing now. And so we can expect that our heliosphere is changing as a result of that. Here we have our galactic cosmic rays. And so we have, a count of our galactic cosmic rays. We know what they're doing. We have good data on this. Here we see the modulation of neutron flux, which is a proxy for these galactic cosmic rays across time, going all the way back to 1965. And so I'm going to turn myself off here. And so you see these cycles. And if you go, up here we have solar minimum, and these troughs are solar maximum, okay? So you'll notice that right now galactic cosmic ray flux is low because we are in solar maximum, and it is lower now than it was during solar maximum in solar cycle 24. It's about equivalent to solar cycle 23, but we may get a rebound out of that much faster than solar maximum for solar cycle 23. This is a fairly long period there. We may, because these coronal holes, start to see that bounce up pretty fast. That could be a thing. If you go back in time, you see that we have had periods where the galactic cosmic ray flux was lower during a solar maximum period, like here at the beginning of the 90s, and actually some really big variations there. If we go up, just to check out our more recent data, you see our 24-hour flux. Nothing really to comment on there, just minor variations. And then here's our 30-day flux. And so you see that galactic cosmic rays are going up. And then we had a decrease because of the G2 storm, and also some earlier unsettled activity here, beginning of May. But now we're back up, and we're actually close to the highest values that we've had galactic cosmic rays for about 30 days now. But again, if we look at solar cycle 25, we see that our galactic cosmic ray flux is low now, but that's likely to start increasing because of these long, persistent, very large coronal holes that are currently on the sun. So I have some research papers linked in the video description discussing the connection between galactic cosmic rays and earthquakes and solar activity and stuff. So if you want to read that, you may. I would definitely recommend you check that out. Here we have our global seismic activity as provided by Volcano Discovery. And you see when the 7th rotation of the coronal hole came in, how all of a sudden, and when geoeffective, how all of a sudden global seismic energy increased. And then we also had, of course, rotation number 8. It stayed fairly elevated. We have gone down a bit, but in general, we've been having more earthquake activity than we were immediately preceding this, as that coronal hole was getting bigger and bigger and bigger with rotation 5 and 6 and so on. But it has cooled off since the 7.4 off the southern coast of South America. And so it'll be interesting to see this picks back up again because our sunspot numbers are quite low, and there's a connection, a correlation, inverse relationship between sunspot numbers and earthquakes. And again, we don't know the exact mechanism of this. It's probably almost certainly multifactorial, but we see that our current seismic activity level for today is high because of that magnitude 6.4 earthquake in Papua New Guinea. And we have our map here on our USGS map right here. And there's the location of that, 6.4 at 15:05 UTC today. And we have had some other earthquakes since then, a 4.9 on the Mid-Atlantic Ridge, and then also another 4.9 on the other side of Africa there. And if we go to our largest earthquakes here, we see that the 6.4 is by far the largest. Again, Papua New Guinea. We see that after that's a 5.6 right on the Mid-Atlantic Ridge in between North America and Eurasia, close to the Azores, maybe it's close to Atlantis. And let's actually go to our 7-day view here, magnitude 4.5 and greater. And we see the 6.4 in Tonga. That was back on the 14th, so nearly a week ago now. Outside of that, 6.4 Papua New Guinea. And the Greece and Tonga earthquake occurred like within 12 hours of each other, basically. That was right as we had that geomagnetic, well, we had a bit of a kind of a burst of seismic activity. Thank you, Curtis, for the super thanks. In H alpha, the sun is looking calm today. There's nothing interesting on my stream on the other channel. Yeah, there's not too much happening with the sun right now other than this coronal hole. It's by far the most interesting thing on the sun right now. That plasma filament did blast off recently. We do have I do have a space weather model from NASA on that now. This is from NASA, and we see a very low density plasma filament, or basically coronal mass ejection, launch out. This is the Earth right there. This is the sun. We're looking top down, western limb, eastern limb. We're looking at basically like the particle density of the solar wind. We see it's not that dense according to their model. We see the propagation mostly going to the north, which does make sense, but it's quite wide. It's like they're really showing a pretty wide shock wave from that plasma filament in our ecliptic view, but they don't show wide propagation on our south-north view. So I think this is going to be stronger than they show here, and I do think it's going to sweep by the Earth. It's not going to be a direct impact, but I think, you know, the last one was the G2. I think this one could be stronger. So we do have that coming up, very likely, or we should perhaps, you know, there's going to be a higher likelihood of something occurring right around May 22nd, 23rd. That is the expected arrival time for that. But in general, yeah, right now the sun is fairly calm. If we go to our 30-day view for earthquakes, we can do 30 days, and you see that the largest magnitude, again, that 7.4 off the south coast of South America. But this earthquake we just had today is one of the largest because it's a 6.4. So we see the 6.4 right there. It's tied for third place with two other 6.4 earthquakes. So yeah, earthquake activity is still high. There's a time delay. What they found with some of this research is that there's a time delay between the high-speed stream and the galactic cosmic rays and the earthquakes. So that's something important to keep in mind. And let's actually look at the heliosphere here. So here we have the sun, and we see that it's emitting the solar wind in this magnetic field. So you have, the polarity depends on what solar cycle you're in because it flips every 12 years. But what they found is that the heliosphere has a lot of dynamic qualities to it. It has like these bubbles that form at the edge, and there's like ripples and disturbances and ribbons and knots, and it's a quite complex structure. And so you add complexity, even more complexity onto it if you have these high-speed streams constantly running out. Now remember, during solar minimum, those coronal holes are typically packed at the poles. And so you have those high-speed streams going out like this. But right now we have them going out more along the ecliptic plane. And so that's really going to be affecting the dynamic pressure of the solar wind in this zone facing towards the heliopause, which is taking the brunt of the energy from the interplanetary or the interstellar medium. And so we can expect, you know, that may not be the case, but we can expect that this heliopause is actually shrinking in closer to the sun and all the planets. This is about 100 astronomical units. Earth is at 1 AU. There's evidence, you know, loose, don't take this too seriously, but there is some geologic evidence that maybe 2-3 million years ago, the heliosphere was only like 0.5 astronomical units across, and the Earth was actually in the interstellar medium until, you know, for most of its orbit around the sun, and it would cross in and out of the heliosphere because the interstellar medium was very, very dense. So there's some really interesting geophysical dynamics, and how that affects the Earth geophysical system and the global electric circuit, climate, and more is really interesting too, because galactic cosmic rays, they can trigger cloud formation, and of course that has a broad variety of effects as it relates to planetary albedo and heat trapping and weather of the troposphere and lightning activity, and that's the global electric circuit, Earth electrification, and more. So it seems that when solar activity is weaker, you have and you have more galactic cosmic rays, that seems to correspond with ice sheets getting bigger. And so, for example, like the Laurentide ice sheet grew a lot during the Lachamp excursion. And I can turn this on so you can kind of see what I'm talking about. During the last ice age, there was a huge ice sheet that covered over Canada, parts of North America, the Laurentide ice sheet. That seems to have really grown significantly during the Lachamp excursion when Earth's magnetic field strength really decreased, let in a lot more galactic cosmic rays. You know, just one factor in this, but there was also a series of grand solar minima that occurred at that time frame during that time. And so if we, you know, let's say this is just the beginning of a long dynamic that's about to start playing out. We don't know. But if it is, we could maybe perhaps start to see things turn in terms of global climate. Instead of it getting hotter, maybe things start to get cooler. And we know we're in an interglacial period. Those don't last forever. At some point, I'm sure the Earth will shift out of this glacial system that's in. We've had hothouse Earth before. We've had snowball Earth. We've had all these different types of Earth. In general, the Earth is electrifying though. So galactic cosmic rays seem to be a pretty important part of that Earth electrification process. So that is what we have right now active with the sun. And the heliosphere, based on that data, appears to be weakening. At least that's what that would suggest. Here we see our coronal hole 9 times now, again. So this has been a factor for a while. Though it was very small there, but if it keeps persisting on the sun, we get rotation 10, rotation 11, rotation 12, then how that affects the heliosphere for the foreseeable future and going into solar minimum, right? We're only going closer to solar minimum now. We're in solar maximum, but every day takes us closer to the descending phase and solar minimum, when you would naturally expect the heliosphere to be weaker. How this is going to set us up for that period of time too, it's also very interesting, because any changes that occur now are of course going to influence the future state that we'll have then. So this is a story that I'm tracking. There is a lag time, it seems, between these galactic cosmic rays and earthquakes. And it also, there's some evidence to suggest that the galactic cosmic ray flux and the modulation of that is also related to dynamic processes of the Earth geodynamo. But we know that we're getting more of them coming into the solar system right now, just because the fact that the heliosphere is weakening. How much is weakening, how significant that is all data that we won't have until we are able to collect enough of it and crunch the numbers. But I'm sure that in 5 years' time, we'll be able to look back on solar cycle 25 and have that data on the heliosphere, because they've been doing that with the IBEX probe for solar cycle 24, and even going beyond that. So this is an interesting question from Savage. Thank you for the super thanks. Can we build a real life shield like in Star Trek to prevent Earth from frying? Yeah, I don't know. I don't think these changes are necessarily bad. I think everything happens for a reason. And so we saw, like, for example, during the Lachamp excursion, the Neanderthals, they disappeared. We saw a lot of megafauna, like there was a megafauna extinction, I believe is in Australia, whereas in North America they were able to live up until the Younger Dryas event. But all of these changes have led us up to now. So it's also galactic cosmic rays are very vibrational. You know, they can interact with our body biologically and DNA, things of this nature. Everything happens for a reason. So it's just getting used to the changes. The Lachamp excursion took like 1,000 years to happen, where you had the magnetic field, it then decreased, and then it rebounded. So in one human lifetime, yes, there's going to be changes, maybe to the climate, weather, things of this nature, right? But it's not like it happens in 5 years and you're like, duh, and you get blasted and then you just incinerated by the sun or something from some flare. Like, that's very likely not going to be the case. These are long-term changes that unfold, and we're very adaptable. So long as we are acting as stewards of the Earth, I think that we'll be fine, and this will take us to, you know, a new, better Earth, hopefully. That's the idea, that's the goal. But we don't know when that's going to happen, how it's going to happen, what that's going to look like, but it all comes down to faith. If you have faith that things are going to work out, I think then everything will work out. So I'm not worried about these changes, just trying to accurately, as best I can, kind of see what's happening, forecast that out, share that with you all. So if you like that, then you can subscribe to the channel. I've been your host, Stefan Burns, geophysicist, space weatherman, and more. We track what's happening with the sun, solar activity, space weather, but also planetary resonances. Again, this shift with Saturn and Neptune from Pisces to Aries and back and forth across that boundary at that 0 point energy. And some of the other evidence about global seismicity and volcanism really has me kind of closely looking at what's happening, especially with the Ring of Fire, which is why I wanted to jump on the live stream to talk about this magnitude 6.4 in Papua New Guinea, because it's the first significant earthquake we've had in a few days. We've had a little bit of a reduction, and it is in this Ring of Fire. So we discussed that, geologic events, geophysical energies, and of course these cosmic forces like the galactic cosmic rays. So if you like the sound of that, then please subscribe. Thank you all so much for watching. Wishing all of you well. Please take care of yourselves. We'll see if this plasma filament impact comes in around May 22nd, 23rd. We do have a very large sunspot group rotating towards Earth center and direct over the next few days. Let me show you that. This is going to appear in less than a week's time. We'll see if it remains quiet or if it wakes up and does something. I don't know, I'm kind of getting a little bit of an intuition that we're going to get something from this, but and what the significance of that is, I don't know. But I described that in my last video with solar cycle 15, how that was very similar to what's happening right now. But here we have our intensitygram for the far side of the sun. So in about 5 days, that is going to rotate towards the eastern limb, appear on the Earth-facing side. And so in 12 days' time, it's going to be Earth center and direct, around 12 days from now. And that will take us right to the end of May, beginning of June, and that will be after Saturn moves into Aries. And so it's interesting. I've been thinking about this for a while. I was actually thinking a while back that Saturn moving into Aries would cause a sunspot number drop, because Saturn is like a limiter, it's a block, it's fallen in Aries. And so it makes sense that we would see some sort of like limitation and drop or block in solar activity, but it's also a manifester, makes things real, finally gives you that end result. And right now we're in solar maximum, the sun is exalted in Aries, and so an expression of that would be like, okay, we're going to drop sunspot numbers, but we're going to give you a huge solar flare, a huge coronal mass ejection. That is kind of resonant with the archetypal expression of Saturn in Aries. And so that's going to be right in that strike zone immediately after Saturn crosses into Aries for the first time, with Neptune there, and again, that historic conjunction at 0 degrees in 2026. They nearly get there conjunct at 2 degrees in July, which is when all these prophetic visions of people, that they've had, like this July 5th, 2025, big volcanic explosion in between like Japan and Thailand. Who knows if that's going to happen or not? I hope it doesn't. It doesn't sound good, but it's a Japanese person and a Thai person that both independently had that vision. So that's kind of interesting. So I'm paying attention to that too. Lines up with the astrology, the archetypal energies. And so, but we'll see if this gives us any activity. It has not been active on the far side, or else we would have seen coronal mass ejections blast off, right? We would have had those signatures show up in the chronograph. So it's been quiet now for a while. Hasn't really done much for a while. We'll see if it wakes up though, because this is the biggest sunspot that's on the sun right now in general. There's no bigger sunspot than this one right now. So we'll keep an eye on that too. Please subscribe. Again, take care of yourselves, because right now we may be in a bit of a solar activity low, having now come off of that G2 storm. We've had a lot of activity recently. We may have that plasma filament come in. Now it's just a little bit of a lull, so do what you can to rest if you're really sensitive to this stuff, because more is likely to come. We're likely to rebound out of that sunspot number low that we're going to have for May, and we may have quite a bit of solar activity for the rest of this year going into 2026, because we are still in solar maximum, though right now we're having kind of an odd expression of that with these coronal holes and the big sunspot number drop. And we'll see how that relates to earthquakes. I'll keep you up to date. So thanks everyone. Wishing all of you well again, and I'll see you all very soon.